So miles per hour, meters per second. So just make the corrections, okay? So to go to meters, I know that 1 mile has 1,609.3 meters, right? You cancel out the miles. You know that 1 hour has 3,600 seconds. If you need to add that to your study sheet, make sure you do so. The hours cancel out with the hours, so you multiply across. So your final answer should be 20.12 meters per second, okay? That I'm not showing you the work. I really emphasize show me the work in between, right? Every step counts. So I would want to see a big number up top, a big number at the bottom, and then you divide to get your unit rate. This is actually a unit rate. What is a unit rate? Is when it's something out of 1, right? This is 20.12 meters for 1 second. So if you divide top and bottom, you will get a unit rate every time, okay? That's what that is. And then if got 350 millimeters for 1 second, that is actually a unit rate. You want it in yards per hour. So how are we gonna do that? What did I do here? I turned that into centimeters. So I know that 1 centimeter has 10 millimeters. Cancels out the millimeters, and then I turn centimeters to yards, knowing that 1 yard had 91.44 centimeters. If you don't have this, then add it to your study sheet. It's going to help you, right? And then we want to turn the seconds into hours. So 1 hour has 3,600 seconds. So this one was a bit more work. What if I ChatGPT or if I Google a rate, Mr. Dirksen, that makes it easier? Can I add that to my study sheet? Absolutely. If you find one that's going to help you, just go for it. So you multiply across, you get a big number and a big number, right? But at the end of the day, you get 831.13. Sorry, I'm looking at the wrong key. I was looking at the wrong paper, guys, sorry. This is 1,377.95 yards per hour. Okay, that is the final answer. Here we've got 1 gallon jug of orange juice and 2 bottles of 750 for $3.99. Determine the unit price per liter for each store. One thing that I need to clarify when it comes to comparison, when you're comparing, we're assuming we can buy partial quantities, okay? Okay, so unit price per liter, it does say per liter, so we're gonna focus on liter. So that means that Superstore is always put dollars at the top, amount divided by quantity. In fact, if you go to any store, it's gonna be dollars per, it could be per 100 grams, dollars per pound. It's always dollars per whatever you're buying, okay? 1 gallon is the equivalent of 3.79 liters. So you could actually just, instead of going 854 in 1 gallon, you can just write it like that. It's probably gonna save you time. When you divide that, you get 225 per liter for Superstore. If you look at Sobeys, you need to watch out a little bit. There's 2 bottles at 750 ml, so that's 1,500 ml. Okay, let me just move this down. And I'm going to turn that to liters real quick. I know that 1 liter has 1,000 milliliters. Is that on your study sheet? Did I give you that one? I hope so. 1 liter has 1,000 milliliters. Okay, you cancel that out and you get 1.5 liters. Now you can do the cost analysis. So it's $3.99 over 1.5 liters. If you divide that, you get $2.66 per liter. So, right, like there's 2 marks here. Or this one would be 1.5, this one is 1. So that's how I would have marked it, because there was a bit more that met the eye here. Okay. And then which one offers the better buy? So this would be dependent on your answer. In my case, it would be Superstore. Superstore. And this is buy. I would go, if I subtracted, it's 41 cents per liter. Don't use cents. Like sometimes students use the C. If you're going to use a decimal, then it's dollars, okay? We know that that's 41 cents, but we're using dollars. It's almost like using milliliters versus liters, right? So we want to use dollars here for that answer. So there we go. That's part B. The fuel economy, I think I'm going to leave that. What was the trick on that one? Fuel economy, just make sure you use this formula. It's liters divided by distance times 100, right? So that's the one you want to use. So the one thing to watch out for is am I given liters? If not, do I need to convert? Okay. Am I given ounces? Am I given gallons? What is it? So you want to convert that to liters. Distance, is it in miles? You want to convert it. Is it in yards? You want to convert it. This has to be in kilometers. So liters, obviously, and distance is going to be in kilometers. Okay, so you want to make sure this is in liters, this is in kilometers. So if you want to undo this and just say liters over kilometers, that's probably, then you have the units and you know where to put what. Okay, so I'm just going to leave that. This one I wasn't too thrilled with. Okay, so there was a video that I made. I asked you to watch on scale diagrams. Right now I don't know the page number, but there's a couple of things you need to watch out for. So if there's a scale, that is huge, right? Like it's telling us. Remember, if it's scale, what do we have? If it's a diagram, we're telling that on our diagram, right? Whatever is on our diagram is going to equate to a certain amount in real life, so actual. That is what you are reading. So you're saying 1 centimeter on my piece of paper is 5 feet in real life. Okay, that's what's happening there. So, in my opinion, this is very easy to do the calculations. Watch this. For the 25, I'm going to do this. 1 centimeter is the equivalent of 5 feet. You don't have to convert. So the 25 feet goes here, and then you call this x if you want to. So it's 25 times 1. Watch this. 25 times 1, which is just 25, right? And then we're going to divide by 5. So x is going to be 5 centimeters. Okay? If you do this once, you don't have to show me this over and over again. Just use this as your model. What are you doing with this number? You're going to multiply it by 1 divided by 5, correct? To get this. So this is 5 centimeters on my paper. This one, you're going to pretend that the 7 is here. So it's 7 times 1 divided by 5. That ends up being, let me check here, the 7 converts to, hold on, 7 divided by 5 essentially. This is 1.4. 1.4. This is 1.4. If you divide this by 5, you get 3.6. Okay, so 5, 3.6. Here you have to do a little bit of math, right? You got to go 25 minus the 7. That gives you 18 feet up here. And you already converted 18 feet earlier, so that's the equivalent of 3.6 centimeters as well. Here you have to do a little bit of math. There's 18 here, take away 7. That gives you 11 feet. 11 feet, if you go 11 divided by 5, you get 2.2 centimeters. So this is a little bit of a complex, lots of conversions, I guess. But now I will use all of the ones I've converted to centimeters, all of these numbers. I will use those now to make my diagram. And now you need a ruler for this, okay? You need a small ruler for that. And I'm going to start here. So 1.4 centimeters. So that would be 1.4. And here this should be 5 centimeters along the bottom. So you take your ruler and you actually make a 5 centimeter line, right? That's this part. And then I'm going to go up by 3.6. 3.6 is right there, so I'm just going to go up. And then another 3.6 this way. And this is a 2.2 centimeter drop. 2.2. And then just close it there. That should be also 1.4 centimeters if you did that right. In general, we still label it with the actual dimensions. Like this, okay? This would be 18 feet. This is 11 feet. So now you've actually made a scale diagram. Everything is to scale, okay? It actually makes sense that this is the longest side, right? It's 25 feet in real life. It's 5 centimeters on my paper. This is 3.6, and so forth. Everything is drawn to scale. So this is my diagram, or you can call this the blueprint, right? That's your blueprint that you're going to use to actually build this room, let's say. Okay. So that's how you do so you need to show me at least one calculation because use that scale and pick any number, and once you do that you can just repeat it. So for every side, like let's say you do 7, replace 7 in here, repeat the process, right? And so forth, and you should be able to do that, okay? How do I check this? I actually cut this out, and then I'll just put it over top of yours. If it's close enough, like I'm not gonna split hair, right? I'm not, so, oh, you're off by like a micromillimeter, like I'm not gonna do that. But if mine doesn't fit your scale, then it's gonna be off, right? So you gotta watch out there. It's usually worth 2 marks. So just be ready for that if it shows up, okay? Back side. So this is my review for you guys here. So the back side, we were doing some painting and some flooring again. 2 coats of paint. You're doing the wall and the ceiling. We're not doing any primer here. We know that a can covers 200 square feet and costs that much. We're also installing new flooring. I'm going to switch colors here. The flooring, vinyl planks that cover 4 square feet each, and each box has 6 of them, and it costs $147.50. When it comes like boxes of 6 and each of them covers a certain amount, I would just go 4 square feet times 6. You know that it's 24 square feet per box, right? Like just multiply and then just get your amount per box. It's much easier to work with moving forward. Okay, the kitchen is rectangular. We've got length, width, and height. There are 2 windows, so now you've got to watch out with that, right? There are 2 windows. This one I actually didn't mind. Like when I looked at your answers, for the most part, they did look good. There are 2 doors, and the area where the cabinets are installed takes up to 260 square feet and does not need paint. So you got to watch out. These are cabinets, right? They take up space. We don't want to paint there. So it's another curveball there. What's the paintable surface? So let's figure out the surface area. We're doing the ceiling, so it's length times width plus 2 times length times height plus 2 times width times height. So length and height, width and height. These are my walls right here. And this is the ceiling. Okay, so you gotta make sure you understand. If it's just the walls, you don't do that first part. If it's the walls and the ceiling, you do that. Okay, so let me see here. If you do that, I'm gonna just go dot, 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 okay? You're gonna be the masters of that. You get 824 square feet if you do the walls and the ceiling. So this is important. Then we're gonna go paintable, right? Paintable, we go 824 minus 2 windows. So 2 windows that measure 4 by 4 minus 2 doors that are 4 by 7 minus just the surface area where the cabinets are gonna go. If you do that, you get 476 square feet. Now this is the paintable surface area. Okay, that's the one I want. That's the one that gets paint, okay? What's the cost of paint? Sorry, that's a typo. This was painful, Mr. Dirksen, so yes, leave that, right? The cost of paint after tax, so you do 2 coats. So you go 2 times 476. That is going to be 952 square feet that needs to be painted. We go 952 divided by how much 1 can covers, and that is 4.76 something. So we need approximately 5 cans. All right. Now the cost: 5 times 85.99 times 1.12. That gives you 481. There's your cost of paint, the cost of installing the floors. I'm going to just do area of the floor. It would be length times width. So it's the 14 times, what happened there? 14 times 16. That is 224. I saw that a lot, so that's a good sign. And then you need, you go 224 divided by 24 because I've determined that 1 box covers 24 square feet. I did that earlier already. That gives me approximately 9.33. Let me just get that right. Yeah, 9.33 something. Can't have that. You round up no matter what. No matter what. As soon as you have a decimal, when it comes to purchasing items, you round up. 10 boxes I need, and so this will be after taxes. I'm asked to figure out, so 10 times 147.50 and multiply by 1.12. This number I saw a lot. This one was all over the place, so that's a good sign. So you know how to do your flooring. Now we get to the scale factor component, okay? Determine the scale factor used to create a new shape, stated in 3 formats. So if this is original, then this is new. So watch out. Am I using original? Am I using actual? What kind of wording am I using? Okay, step number 1. Step number 2, how do I do the scale factor? You got to watch out carefully. Is it linear? Am I given 2 dimensions, like the length and the height or the radius? What is it? What am I given? Is it areas or is it volumes, right? Or capacity? In this case, we can compare the height of this triangle with the height of that small triangle there. So I compare these 2 sides. It's just linear. So it's 2.7 centimeters, 7 inches. What's wrong with this right now? Ranveer? The units, exactly. Scale factor can't have different units. In fact, we want to cancel them out. So we know that 1 inch has 2.54 centimeters. cancel, 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 cancel. You end up with 2.7 at the top, 17.78 at the bottom. Now, this is where your calculator comes in, right? If you're asked to do state this as a fraction, sure, you can multiply both of them by 100, but you can also just go 2.7 divided by 17.78, math, fraction. So it's 135,889. So this is the fraction format. Then I turn that into a decimal. I go you choose which one you want to use. 2.7 divided by 17.78. This would be 0.15 as a decimal. And here, watch out, this is for grade 12 as well. If you state this as a percentage, don't go by that, go by your screen. So I will multiply my answer by 100. Now I state it as a percentage. It's 15.19%, because there's a 5 after the 8, right? 5 or greater bumps up. So here are your other two formats rounded correctly. So convert, and then do your fraction if you need to. Next, a cylinder has a capacity, and you see the units, so we're talking volume, right? A new similar cylinder has a capacity of this. What's the scale factor? We're going to use this one. We have to use that formula, right? Okay, so plug in. We don't know the scale factor. This is new. So new goes up top. Original goes at the bottom. You're almost there. What do I need to do now? Anyone? What happens now? Cube root? You got a cube root. Yes. Don't cube anything, because guess what? Look at this. Is there a cube anywhere on those numbers? So it's not asking me to cube anything. If I would cube anything, it would be my scale factor, but I don't know it. So my goal is to get rid of that cube. So you actually cube root both sides. Okay? That is crucial. You're gonna lose a whole mark if you don't do that. Okay? So the way I calculate that, I would figure out what that is. It's 421,875. So I'm not done yet, right? I'm just and if there are more decimals, just go dot 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 after. This one actually stops there. And once I have divided, I found the quotient, right? You go math, cube root, copy, paste, and then I get my answer, which is 7.5, which I also saw a lot. I did see that. I don't need to state it as a fraction. I don't need the percentage because I didn't ask you for it, okay? The new cylinder is how many times larger? Okay, so here's where I didn't see the right answers. This translates to, if you multiply that by 100, it's 750%. This one, scale factor. You multiply it by 100. If you're confused, I multiply this by 100 to get that. So this is 650 times larger, because you go 750 minus 100, right? It's always like the new scale factor tells me how much have I increased from 100, and it's increased by 650%. Okay, so you got to watch out for that. Last but not least, there's a smartphone has a screen with 15 squared inches. A new phone has been designed with a scale factor of 4/5. I would like you to know that that's 0.8 or 80%. We know a reduction has happened, right? It's going to be a smaller phone, a smaller screen. We know that, okay? So expect a smaller surface area. Calculate the area of the new screen. Area, okay, so we got to use this formula. Area of new, area of original. We have the scale factor, so plug that in. Substitute in the scale factor. Let me move this up for folks in the back. Over on this side, I know the original surface area. It's just area, not surface area. I want to know the area of the new phone, the screen surface, right? So you have it like that. Square both of these numbers. You get 16 over 25. Area of new. And this is 15 like that. Cross multiply and divide. So that's 16 times 15. Make sure you show your work. That is 9.6 squared inches. I did see this number a lot. Some of you, I would say you need to show me a little bit more work. You don't have to have this formula. I don't need to see the actual formula, but I do need to see the substitutions and the squaring and all of that. Okay? The new screen is how many percentage smaller? I saw 36% for some reason, a lot. That's not quite right, because K 4 over 5 is also 0.8, which is also 80%. You can go equal sign because it's an exact, it's finite. So we go 100 minus 80, there's a 20% decrease. Okay, so the new screen is 20% smaller. It doesn't say the area of the new screen. Maybe that's what threw some of you off. It says the actual phone is this much, this new screen is this much smaller. So the object is this much smaller, okay? All right.